Hi people, so today we're talking about 3.5 conditional statements, and this is totally different kind of topic than the Venn diagrams. It's just another part of set theory and logic that it's more about the logic, kind of like the philosophy part of it almost. It's really nothing to do with Venn diagrams anymore though. So let's start this off. Here's a couple good things to have on the study sheet perhaps, because it's hard to keep them all straight. It's a lot more of the terminology that we started with at the beginning of this unit. So a conditional statement. It's an if-then statement. As in, for example, if it is Wednesday, then it is early dismissal. That's right, late start. Then it is late start. Who doesn't love a good Wednesday? I put that in little quotation marks because it's like a little sentence. Now notice a conditional statement always starts with an if, and then kind of halfway through-ish, it says then. So if it is a Wednesday, then it is late start. If I like apples, then I'll probably eat apples sometime during the week. Maybe I need to buy some apples at the grocery store. So if I like apples, then I should buy some apples at the grocery store. It always starts with if, and then is always halfway in between somewhere. All right. The hypothesis is the assumption. It's the first part. It's the if part. If it is Wednesday. That's the hypothesis part. That's the beginning. So if it is Wednesday, that's kind of like me saying, is it Wednesday today? I don't know. Yeah, if it is. The conclusion is the second part of the sentence. The result of the hypothesis. Then it is late start. So it's the second part of it. That's all. Alrighty, here's another one. Counterexample. A counterexample is one example that proves something wrong. So, for example, if it is Wednesday, then it is late start. There's supposed to be a T right there. Is disproved by the counterexample. There's no school on Wednesdays in both July and August. Because if you're in July and August, well, there's no school at all. So I guess it's not late start. Or if schools are closed, then there is no late start. You know what I mean? You wake up and you get to it. So you only need one counterexample to disprove something, and it's just a tiny little statement that says, okay, well, it's not true in this example. So you usually only need to think of one. You don't need to think of a bunch of them, just one. All right, converse. All right, a converse statement is a conditional statement, so it's an if-then statement. Excuse me, in which the hypothesis, so the first part, and the conclusion, the second part, are switched. Now notice, the if and the then stay in the same place, but the other parts of the sentence switch. Sometimes you have to reword it just a tiny bit for it to still make sense, but the if should be at the beginning and the then should be halfway through. So in this one, the converse would be, if it is late start, so I put the conclusion first, put a little comma, then it is Wednesday. So you keep the if and the then, but you switch everything else, and if you have to make tiny little grammatical changes, you do, but for the most part, you just leave it as is, and that's totally okay. Alrighty, a biconditional statement is where the conditional statement is true, that first original statement is true, and the converse is true. So when you can go both ways and it's still true, then we call that biconditional. Both the conditional and the converse are true. I don't know if you heard my dog grunting in the background there. She makes lots of noises. Okay, so biconditional, the conditional is true and the converse is true. And so sometimes we say if and only if. Like, it is Wednesday if and only if it is late start. So we put the if and only if kind of in the middle. But if and only if says that it is a biconditional statement. Oops, not two ends. If and only if. Now, this statement was actually not true, right? Because we did come up with counterexamples. So I would say that that is not a biconditional statement. Because, yeah, not true. So one part of it was not true. The whole thing is not biconditional. Alrighty. Here's some notation that we use. Don't we just love notation? We put a P and a little Q with a little arrow in between for saying that this is a conditional statement. So this is our way of saying conditional statement. And we put a two-sided arrow if we want to say it's a biconditional, like it goes both ways. Where P is the hypothesis part and Q is the conclusion part. So P goes to Q, that's conditional. P goes to Q and Q goes to P, that's biconditional. Alrighty, when you flip, switch. Hopefully my dog doesn't start barking at whoever's walking by right now. That'd be kind of annoying for the video, but alright, flip. Alright, everyone's favorite topic. This is called a truth table. Not my favorite thing in the world. So we use truth tables when we want to verify if conditional statements are true or false, or verify when they're true and false. So here's our hypothesis, here's our conclusion. If it is raining outside, then we practice indoors. And a truth table is, yeah, it's going to be a table. So let's start off with making ourselves a table. We are going to have to fit a lot of space in this, a lot of things in this space. So make sure you write just a tiny bit smaller if you got big writing like I do. Okay, truth table. So there's going to be 3 columns, where the first column is going to be the hypothesis. The second column will be our conclusion. And the third will be our result. And what we're going to do is we're going to come up with different cases where different parts of this is true and false, and we'll see if the statement is still true or false or whatever. So the hypothesis is P, if you remember, and then conclusion is Q. And sometimes we see true tables with just P and Q at the top, and then some other kind of symbol at the top here, just because, instead of writing out the whole word. Okay, so here's case 1 that we're going to examine. Case 1. P and Q are true. And then we'll decide if that's true or false. So, if it is raining outside, like currently, right now, it is currently raining outside. Yeah, that's true. So we're saying this is true, and then Q is true. Yeah, we're going to practice indoors. Yes, that is exactly what we're going to do. Is this a true statement? Well, yeah, it would be, because if it's raining outside, which it is, then we're going to practice indoors, which we are going to do. That's a super reasonable statement. So when P and Q are true, this statement is true. Okay, case 2, we're going to switch it up. We're going to make them both false this time. P and Q are false. So it's kind of us deciding that we're going to make them false. And we want to know is the statement still a true statement, or is it now a false statement? Okay, so if it's raining outside, we're going to make that false. So it's actually really nice outside. And we're not going to practice indoors, we're going to practice outdoors. So it's currently nice, and we're practicing outdoors. Is that original statement still true? If it is raining outside, we practice indoors. Yeah, it's still a true statement because we're outside and it's nice. We only practice indoors when it's crappy outside, when it's raining. So this was false, but it's still a true statement. It still holds. So statement is true. Okay, case 3. Let's switch it up again here. P is true, Q is false. So it is raining outside, but we're going to practice outdoors. So maybe it's only like tiny drizzling or something. It is raining, but we're going to practice outdoors. Is the statement true? I'm going to fill in this part. Is the statement true? Well, if it's raining, the coach told us we should be practicing indoors, but we're not. So he lied to us that one time. This is no longer a true statement. So here, the statement is false. So here's one time when that statement didn't prove to be true. Okay, let's try one more. Case 4. We only have 4, so this is the last one. P is false. Q is true. False, true. Oops. Alright, so it is not raining outside. It's nice outside, but we're going to practice indoors. Is that original statement still true, or is it now false? Well, it's nice outside, but we're going to practice indoors. Maybe there's a different reason we're going to practice indoors, but that doesn't make our coach lying to us right now. It's still a true statement because it just happens to be nice and we're practicing inside for some reason. So it's still a true statement for him to say, well, when it's raining, we're going to practice indoors. When it's nice out, we can practice indoors too. Maybe we're just feeling indoors right now. So the statement is true. So here's my truth table. Gorgeous. Great. Let's actually answer the question. I'm going to go to the top of my page for it just because I ran out of space. Verify when this is true or false. Well, the statement was true 3 times and only false once. So therefore, the statement was false only when the hypoth is true and the conclusion is false. So all other times they were true. There's one time our coach lied to us and made us practice outside even when it was raining. This is a truth table. It is not an easy concept. There is essentially this example in your textbook. Please take a look, read it over again, and maybe it'll make more sense from them than from me. Or ask me some questions. Okay, let's try this one. Kind of a second part of it. So the rugby coach's conditional statement, same statement, if it is raining outside, then we practice indoors, is the converse of this true or false? So let's figure out what the converse is. Remember, converse is where we take the 2 parts and we flip them, but we leave the if and the then in the same spots. So if we practice outdoors, if we will you should put a little comma, then it is raining outside. Good idea to actually figure out what the converse is, and then let's decide, is this a true or false statement? So I want to come up with one counterexample, or more than one, but really I only need one to say that this is a false statement, to say that this is not always true. So for example, are there any times that we might practice indoors when it's not raining? What if it's snowing? Well, we might be practicing indoors because it's snowing, or because there's a tornado, or because someone else really needed the outdoor practice space, because it gets competitive in the busy seasons. So I would say this is a false statement. What if it's snowing? If it's snowing, or what if it's winter, or what if tornado? These are examples of time that we might practice indoors. Ooh, This should really be... Oh no, that was right. I don't know why I crossed it out. I'm just making this worse. So just because we're practicing... This is what I messed up. Indoors. So just because we're practicing inside doesn't mean it's raining. It could be snowing, it could be a tornado, it could be, like, what if there's like a wasp infestation or something like that? There are other times we might practice indoors rather than just rain. Let's flip and try a few more here. All right. You know what? This one I'm going to get you to try on your own. It's very similar. Let's try, oh, this one's also very similar. I'd like you to try this one as well. Keep going here. A couple more very similar ones. I do want to do, let's try this one right down here because this is a biconditional statement and it has this form here that says the biconditional statement. So this is on page 17. Mr. Lacko states the following biconditional statement. A quadrilateral is a square if and only if all of its sides are equal. So the if and only if is saying that this is biconditional, and it says it goes both ways. Like a quadrilateral is a square. If a quadrilateral is a square, then all of its sides are equal. Or we could go the other way. If all of its sides are equal, then a quadrilateral is a square. So it should be able to go both ways. So let's think... let's even write those down. Conditional. So I'm just kind of changing it into the conditional form. If a quad is a square, then all of its sides are equal. Do we think that's a true statement? I usually just try to picture a square. All right, draw myself one. If this is a square, okay, yes, it's a square. Are all of its sides equal? Yeah, that's kind of a part of being a square, right? So I would say that's a true statement. Now the goal here is not to test what you know about squares, but hopefully that's something you know about squares already. Let's do the converse now. If all of its sides are equal, then a quad is a square. Now we have to decide if that one's true or not. If it's true, then this whole thing is biconditional. If it's false, then the whole thing is not biconditional. So I want to think to myself, is there a shape where all the sides are equal? Like a four-sided shape. Is there a four-sided shape where all the sides are equal? Hopefully you're thinking, yeah, there's a rhombus. Rhombus looks like this, where all the sides are equal. But it's not a square, is it? So I would say that this is a false statement. Because a quadrilateral is a square if and only if all of its sides are equal. I don't think it goes both ways. I think it only goes one way. So it'd be a great conditional statement, not a great converse statement, and not a great biconditional, by which I mean they're not true. So therefore, not biconditional. All right, here's some homework questions. The ones we skipped here are really good practice. And my answers are up on the Weebly there, so please take a look. So there's some textbook questions. Take a look through the examples in the textbook too. They're often very similar to what I do, and maybe they just say it in a slightly different way that is better for you. Okay, thank you. Have a good day.